Hey all, today we are going to talk about square roots and how we can simplify them. We've simplified exponents. Today we're going to simplify some square roots. A square root is just an operation, just like adding, subtracting, multiplying, dividing. It's going to do something to a number. And if you put square root of 54 into your calculator, it's going to give you a decimal. A decimal we'd probably want to round. Let's look at that. So here you can see I have a decimal. That decimal probably keeps going and going. And so we would eventually round that, which would mean it would change the value of this square root just slightly. And so we don't want to do that. What we want to do is simplify it and write it in simplest radical form. And so the first thing we want to talk about are perfect squares. Perfect squares are numbers that are created by two factors that are the same number. So for example, 1 is a perfect square. 1 is equal to 1 times 1. 4 is a perfect square. 4 is equal to 2 times 2. 9 is 3 times 3. 16 is 4 times 4. And we could keep building these perfect squares by multiplying numbers by themselves. 5 times 5 is 25. 36 is 6 times 6. 49 is 7 times 7. These are some of our more common perfect squares. 64 is 8 times 8. 81 is 9 times 9. And 100 is 10 times 10. Those are the first 10. We could keep going 11 times 11, 12 times 12, 13 times 13. We can build an infinite number of perfect squares if we keep multiplying numbers by themselves. 1 times 1 is the same as 1 squared, and 2 times 2 is the same as 2 squared, and 3 times 3 is the same as 3 squared, so on and so forth. So squaring a number gets us a perfect square. Square rooting a perfect square gets us a number. And you'll see that as we go through these. So when we want to simplify a square root, for example, the square root of 54, we are going to find factors of 54, and we are going to be looking intentionally for one of these factors to be a perfect square. So if you copy these first 10 perfect squares down, that will help you. So 1, 4, 9, 16, 25, 36, 49, 64, 81, 100. If you copy them down, we're going to see what is the largest perfect square we can divide 54 by. And sometimes this takes some guessing and checking. You might want to try a few of these out. You can use Desmos if you need to. I know what they are, so we're going to roll with that in the interest of time. But as you go through and practice these, you might have to try a few. So I know that I can divide 54 by 9, which is a perfect square. And I know when I divide 54 by 9, it's equal to 6. What that means is 9 times 6 is 54. And since this has a square root, both of these factors are going to get square roots. We're just trying to break the square root of 54 up into two things that we could multiply to make the square root of 54, much like we did with quadratic equations. The reason we want to divide by a perfect square is because we know what the square root of a perfect square is. The square root of 9 is 3. That's because 3 times 3 is 9, which we can see right here. And so we can change the square root of 9 into 3. Once you square root a number, the square root symbol goes away on that number. The square root of 6 we can check out is a decimal, so we don't want to actually do square root of 6. We're going to leave it as the square root of 6. And 3 root 6 should be the same as we got for square root of 54. So if I actually type 3 square root of 6, you can see it's the same value as the square root of 54. We just wrote it in a simpler way. It might look more complicated, but in the math world, this is a simplified version of square root of 54. And that is our goal here. We want to see, for example, for 48, what perfect square can we divide it by? We can divide it by 16. So we're going to break the square root of 48 up into the square root of 16 and the square root of 3, because 48 is 16 times 3. The square root of 16 is 4. It's what number we multiply by itself to get 16. When we square root 16, we get 4. The square root symbol is gone, and then we leave the square root of 3 alone. Again, this takes practice. I can see it easier just because I've done it a lot, and the more you do it, the more you will see it. Square root of 147, it's a larger number, so I might want to try dividing it by a larger perfect square. And in fact, the biggest perfect square I can divide it by is 49. If I multiply 49 times 3, I get 147. So the square root of 147 is the square root of 49 times the square root of 3. When we have a perfect square, we can actually square root that number. It's the number we multiply by itself to get 49. That is 7. The square root of 49 is 7. And you can always check that on Desmos. You can always check in your calculator these perfect squares. And you can see the answer doesn't have a square root anymore. Square root of 3 is a decimal, so we leave it alone like we have in the previous problem. And that is our simplified version. One last example, 24, I can divide by this perfect square 4. 4 times 6 is 24, so square root of 4 times the square root of 6 is the square root of 24. We can simplify root 4. It's a perfect square, so we can take the square root of it and get 2, and the square root of 6 stays the same. So I want you to try one of these. It's helpful if you have written down the perfect square so you know what to try to divide 72 by. Give this one a try. When you're entering your answer, use SQRT and then in parentheses, use this to represent the square root symbol if you need it. So hopefully you got 6 square root of 2. If you didn't, please call me over and ask me for help. Let me take a look to see what you did. If not, move on to the next piece. So we can also simplify variables that are underneath square roots. And that's a little bit different. If you remember when we did exponent rules, when we multiplied, for example, I'm going to use the letter K here, K to the first power times K to the first power. When we multiply square or variables with exponents, we actually add the exponents. So K to the first times K to the first is K to the second. When you square root something, we're pretty much asking ourselves, what did I multiply by itself to get this number? Or in this case, to get this power that has a variable. So when I look at K to the second power, that's K to the first power times K to the first power. So I can square root this, and I'm going to break this up. I can square root K to the second power, and that is K to the first power, because K to the first times K to the first equals K squared. A square root is just asking, what thing did I multiply by itself to get this value underneath the square root? And then we can do the same thing with 18. 18 is the square root of 9 times the square root of 2. 9 is a perfect square. The square root of 9 is 3. I'm going to put the K next to that 3, and then square root of 2 doesn't change. If you haven't noticed, we can break these squares up that are being multiplied, these square roots, into individual square roots. So I like to break up the numbers and the letters. 75 is the square root of 25 times 3. Square root of 25 is 5. Square root of 3 is a decimal like we've seen before, so it stays the same. Now let's look at x cubed. We want to break these variables up into exponents that are even numbers. We want even numbers. like 2, 4, 6, 8. And so I can rewrite x cubed as x to the first times x squared. And so I can square root x squared, because this is something, basically we're dividing by 2 to figure out what the square root of a variable is. So x squared, that exponent divided by 2 is x to the first power. And then we can't divide this 1 by 2, so it says it's the square root of x. So I like to rewrite this with everything that's not in the square root, and then everything that is in the square root. This is probably very new. This might look a little complicated. If I'm going too fast, pause, raise your hand, ask me for help. That's what I am here for. Let's do another one. We just did the square root of 72 in our first U-try, and so I'm just gonna go ahead and say that is 6 root 2. X to the fourth, since that's an even number, we can just divide that exponent by 2 to square root x to the fourth. 4 divided by 2 is 2. And so that means the square root of x to the fourth is x to the second power. And so I'm going to write that actually in between this 6 and the square root of 2. And there we have that one simplified. There's no x left over underneath the square root because this was an even number. I didn't have to break it up at all. And so it gets completely square rooted. I think we square rooted 24 before. And we got 2 root 6. This is n to the first power. 1 is not an even number. We can't divide it by 2. We can also not break it up. There's only one n there. And so that n has to stay underneath the parentheses. We can't square root it. And that's as simple as it gets. So before you try this one, ask me for help if you struggled at all or were confused at all. Please do ask for help. That's the point. If not, give this one a try. So hopefully you got 4x times the square root of 2x. Again, also we're using SQRT to enter square roots. So this would look like this. If you didn't, please do ask for help before you move on to the practice. It's good to make sure that we fix any misunderstandings before we practice it too many times. If you've done that, please move on to the practice. There are 8 of them. Give them a try. Take your time on these. If you get stuck at any point, ask for help. It's a good idea to make sure that you have those perfect squares written down so you can access them and use them to help you. As ever, if you need help, ask. Good luck.